welcome to a chat about autonomous vehicles. I don't know how we're going to fill up a half hour. It's going to be really, really tough. Yeah, I just figured we'd bring out our speakers and they can introduce themselves individually real quick, kind of tell us what their role is and where they came from previously, what they're doing now. Go for it.
Great. Hello, everyone. I'm Jennifer Haroon. I lead strategy and business operations for a startup called Nauto. We build an intelligent camera system that helps human drivers drive more safely. And then we also use our technology and our data to help autonomous technology developers improve their development. I previously was at Waymo, where I also led business operations for about 3 years and did other things at Google before then.
You'll have to tell us all about that.
Hey guys, I'm Stefan Seltz-Axmacher. I'm the CEO and co-founder at Starsky Robots, and we're a self-driving truck startup. I'm actually probably the least qualified person in this entire room, which is a good place to be on stage. Before this, I was just a sales guy, and I randomly had this big idea about trucks that has gotten me where I am today.
Interesting. Hello, my name is Justyna. I'm with NVIDIA. I'm overseeing global business development, ecosystem growth for mapping, safety, and recently simulation. And before that, I've run a couple of startups, one of them more successful than the other. I've been with Intel, with MathWorks, with the White House, with Harvard University, and in Germany with multiple OEMs consulting.
Cool, and my name is Amir Efrati. I'm a reporter at a technology news publication called The Information. If you don't know The Information, we're subscription-based, and we try to tell you things you didn't know before, which is kind of all that we do. So, real quick, before we get into a few questions, and I want to open it up to audience questions as quickly as possible, but real quick, just so that I understand the kind of developers who are here, how many people here are technical engineers themselves? Okay, so a good amount. And how many people here are working at a startup or a company that is tangentially or directly related to autonomous vehicles? Is that most of you? Mm-hmm. Many of you? Okay, at least half, okay. So that leads me to my first question, which is a bit broad, but when it comes to the companies that are going to be operating and actually deploying autonomous vehicles of various kinds into the public realm, what will they be building themselves and what will they be outsourcing to developers like the folks out here who probably work on maybe mapping related services or simulation related services or teleoperations and things like that? What's going to be built in-house and where is there still a huge opportunity for developers that want to service those kind of quote unquote full stack players?
Maybe I can start. I've been doing safety critical systems my entire life. So there is this one thing about safety critical systems that there's not much opportunity to outsource the critical functions of your software or even system design. When Amir asked us that question before we joined, I told him there's no way you can do that. But then I thought about it, and actually there is a couple of things that you could do. One of them is data collection. So what you need for autonomous vehicles is you really need a lot of simulation data and data sets so you can train your AV system so that it can learn from it and never make a mistake. And the more diverse and the more redundant data you have, the better, which means you can outsource the data collection given that the sensor setup is correct and the hardware setup is correct and whatnot. But there is opportunity there.
Kind of going back to the safety critical bit. As a frame of reference, if one of you guys drives home from here tonight and unfortunately gets in an accident and kills somebody, due to healthcare costs in the US, due to the litigious nature of Americans, the cost right there of that fatality accident is between $2 and $5 million. And that's just you as a person without much money to sue for. If a truck gets into an accident and a large company is somehow involved, a large company is driving the truck, a large company's freight is on the truck, even just a large company's logo is on the side of the trailer, there might be a settlement in the range of $100 to $150 million. So working with small organizations on safety critical systems, actually for a lot of players in the autonomous space is going to represent an existential threat. So in terms of when are autonomous vehicle companies going to partner with startups versus when are they going to build it in-house, I think it's going to depend on how safety critical is it and how valuable is it. If someone emails me right now, Stefan at StarskyRobotics.com, if someone emails me right now with a single line of code that makes our system work perfectly for the low cost of $100 per vehicle per month, then we'll probably take that risk. If it's a relatively minor thing that doesn't add much value but has the potential to cause an accident, it's probably a non-starter.
I mean, there's definitely players that want to do the whole thing, full stack, end-to-end, almost everything themselves. But it's still relatively early days, especially when you're talking about full autonomy. And there's a lot of companies that feel like they're playing catch-up. And so while I agree that safety critical systems, I think, are very hard to outsource or at times even partner with, I think there are other functions. We're at Mapbox's conference, so I think mapping is one good example where you can partner with another company to work on. I totally agree on data collection. I think that's an area that Nauto works on. And I can imagine that there could be certain algorithms that perhaps aren't as safety critical, but in some ways still enhance your system. That might not have been created yet that would be interesting to players. So, you see a lot, particularly with the OEMs, which are in some ways trying to play catch up. And unless they want to, buy a full stack AV developer, they're looking at what they can build in-house and what they can really partner with. And I think that's something that's changed over the last couple of years.
And you think even with the companies that claim to be fully integrated, like Cruise or Waymo, that, I don't know, maybe they're outsourcing a bunch of stuff, they just would never talk about it?
I would not make that assumption. Maybe one thing to clarify is, how do you define autonomous vehicle? Is it just the autonomy of driving, or does it include driver monitoring, human-machine interface, and all the infotainment functions, maybe augmented reality functions? Those you can obviously outsource.
Yes.
But the autonomy as such, the typical learning from the data set, and then planning, perception, and control, I don't think anybody's going to ever outsource that. And there's a very simple reason for that. If you think about functional safety and the ISO 26262 standard and beyond, you have to get your system certified. And to get the system certified, it means to get the software certified, hardware certified, software, hardware co-design, and then the whole system as such. There's no way out from that. So if you want to be on the road, that's what you have to do.
But the point is, if it's going to be something that might end up killing somebody, that's got to be in-house. That's your point. Right?
And a lot of things can kill people.
Yeah.
Like there's a lot of parts of an autonomous vehicle, especially if you're thinking about an 80,000-pound vehicle, that can kill someone. Mm-hmm. If you are if it's a simple extra algorithm that maybe does additional help detecting certain types of objects, and it's particularly overcautious, and as a 75-foot, 80,000-pound, 60-mile-an-hour vehicle, you slam on your brakes in the wrong way, jackknife, you take out a school bus full of orphans, and that's not cool. That's frowned upon. So
how many people are going to die in the service of, it's definitely not cool, but how many people will die in the service of getting to a better place? Certainly, I mean, obviously Uber has offered us a great opportunity, terrible situation, but a great opportunity to talk about some of the things that are wrong. Obviously, on the software side, they made some pretty big rookie mistakes. We've written about some of that with respect to how their system suppressed the signals that it was getting. But on the driver operations side, clearly it's broken. They had somebody who was not looking at the road. But how many people are, what are we going to tolerate as a society? And also, how many people do you think practically are going to end up dead in the service of training these things in the public to get to a better place?
We're not going to see perfect, right? And as human drivers, we also aren't perfect. Mm-hmm. And as those developing autonomous systems, we also aren't perfect. And so I think the more important question, and the one that you pointed to, is how are developers building in their redundancies, their checks, and their balances? How are they training their test drivers?
But you're
are
always
they
gonna
using driver monitoring?
But you're going to have
right?
the weakest links, right? You're going to have players that go out there that are just not good, right? And will that shape kind of perception and
I think that the issue as an industry is if we have a lot of players who go out there and aren't good and aren't thinking about and acting on all of these requirements, then you are almost inviting regulation that then can preemptively stop or hurt the overall development of self-driving, right? And so as an industry, when we get together and talk, we have to, and some of us do, talk about these types of things like building redundancies, like driver monitoring.
So the question of like the threshold for what's safe enough for testing, what's safe enough for actual public use, whether it's a personally owned, quote unquote, fully self-driving car in a particular place, or a ride-sharing environment that's a driverless, let's say shuttle or the like. What are is it become pretty clear what the thresholds are for the necessary safety? It doesn't seem like we have really good metrics that various companies are agreeing on, and the disengagement stuff that people report on in California is just bullshit. So where are we as an industry in terms of measuring safety, measuring progress, and figuring out when's safe enough to give it a shot?
I think the entire industry has been quite immature in thinking about safety. I mean, even broader conversations about the acceptable number of fatalities in autonomous testing. I've had thought leader engineers who lead big teams at great companies tell me that a good autonomous system should never kill anyone ever. And other people say very publicly it needs to just be safer than a person. And that range is not something you can build
What is
to.
safer than a person, though?
That itself is an issue, because some people are terrible drivers and some people are great drivers.
Right.
Most of us are less good than we think. So really, the industry needs to come together with some of that. As far as the disengagement metric, the disengagements has been a metric that makes a lot of sense and people really like. And for a while, we were tracking it. We thought, hey, we're running, let's say, a 150-mile autonomous freight route. Let's see how long on it we can go with 0 disengagements. Oh, cool, we went 70 miles. Oh, cool, we went 80 miles. And then my co-founder flew out to do a ride-along in this truck that's going further and further without disengagements. And we realized that the safety driver, if there was no other cars nearby, would not disengage the system, even if it was going towards the lane line. The entire idea of using disengagements as a metric isn't working. What we need to get towards is a system that falls in line with ISO 26262, that is reliable, but is especially controllable when there is an inevitable failure, because every system will fail, catastrophically and slightly. And what we need to have are systems that, if the cameras suddenly fall off, if the 2 steer tires instantly go flat at the same time, systems that are controllable enough where everyone doesn't die, if and when that happens.
I give you a technical answer or opinion. There is a lot of people who have an opinion, but the only opinion I think that you can rely on is what is the technology, what are the standards that we are relying on. So for level 2, we have really well-developed standards that we have to rely on, and everybody has to pass them. For level 3, we didn't develop the standards yet. They are in development. There is a software of intended functionality workshop group that is still working on what the standards should be. So the KPIs are not known because they're still working on that. But in general, if you think about the definition, what is the functional safety for a car, it's really straightforward. It has 2 sides to it. One is prevent the accident. The other is, if there is any fault, failure, error, anything happening, diagnose and mitigate the result. So very simple. Either prevent means you will never get into accident, or if there is something happening, mitigate the effect. So give people the ability to either control the car, react properly, or the system should react itself. And on the level 3, You want the system to react. That's why you build in the diversity and redundancy to the entire system co-design.
Stefan, I thought what you said was interesting between building a system that's better than the average person, right, which a lot of people talk about, and then perfection, which I agree is not realistic. And one of the things for me that was really interesting about Nauto and why one of the reasons I joined them is they really were interested in understanding better about human driving, and then you can start saying, well, what is better than human driving, right? And so because we have these devices in commercial fleets, we see in a fleet that about 20% of drivers in a given fleet will basically never cause a crash, right? So those are really good drivers. They might get rear-ended. They might, something strange might happen to them that they can't control. And then you've got about 15% who basically are responsible for about 85% of that fleet's losses, right? Those you would say are the bad drivers. So do you want an autonomous vehicle that's better than average? Do you want them better than these 15% that are causing 85% of the crashes, or do you want them better than these 20% that will never cause a crash? And I think understanding those nuances is something that we're starting to talk about with developers and is an important part of the conversation around safe enough.
So I was asking about weakest links earlier. I wanted to ask about Elon Musk and Tesla Autopilot for a second, which I realize is not fully autonomous technology, but nevertheless, a lot of people think it is errantly, and some of them are no longer with us as a result. Do you think that he poses, or Autopilot poses, any kind of threat to the broader development efforts that might cause good or bad regulation to come about? Like, what do you think the practical impact of Autopilot is on the industry?
I think it's been clear for years that consumers, whether they're super educated or whether they're not, aren't good users of level 3 technology. There's a story I've heard a couple of times that early on into the Waymo program, and I'm sure confirm or deny could happen, that some of the early Waymo engineers set their cars up with early autopilot, and these were the guys who knew exactly how bad the system was, and they were playing on their phone and doing email and doing other stuff. When people ask me, hey, I'm never going to like seeing an empty truck next to me. How are you going to solve that? The reality is, as humans, we're almost trained to quickly trust technology, and that's detrimental when it comes to level 3 autopilot. And I think that's a problem across the board. I know there's other teams that have outright said they're not going to deploy a level 3 system. They're not going to put it in cars they sell. They're not going to make that as a retrofit product for people to put in their own cars. I think it's a product that doesn't really work, mostly because humans are bad.
Okay, but what's the practical impact on? I mean, we see like crashes happening all the time now as this technology actually rolls out. Obviously, other companies, whether it's GM or Nissan or others, are also doing this semi-autonomous stuff. And again, it's all sort of being lumped together with the quote-unquote fully autonomous efforts. So there's a bit of that conflation, but. Is this gonna end well, or could this pose like a problem for the developers that are really thinking critically about safety and wanting to take the driver totally out of the loop?
I think every new technology is giving you an opportunity to define what the challenges of the technology are on the one hand, and on the other, what can I do better? So we are learning about the challenges, and we are as well conceptualizing what can we do better. If you look from NVIDIA perspective, we are a platform for any autonomous machine device. So whatever you prefer, whether it's cars or robots. So what we do is we basically advocate for simulation and running as many simulations as possible in the virtual environment, so that when you go on the road, you are then safe. And from the simulation, you can learn tremendous amount of scenarios that you have never thought about, or you have never encountered, and you have never collected data about. So that's one way to go. And I think the more challenges you see, the more you are convinced simulation is the way to go, because you don't want to experience that. You want to learn from that in the virtual world. So that's one way. The other way we see the autonomy is that compute translates to safety. If you put enough compute on the car, it's going to guarantee safety at some point, because at some point it's going to give you the redundancy and diversity that you need. So the more software you build on the compute, the better for you.
That's a good plug for NVIDIA. And no, your point on simulation is well taken. I think Uber is learning a lot about simulation these days that they didn't know about before. I do want to open it up to questions from you guys since you're all here. So are there microphones around, or actually don't know the process for asking questions? You can shout if you want, but yeah, go for it, right here.
So we have autonomy in aviation.
Aviation, yeah.
So how does their approach towards autonomous flight differ from vehicle?
Yeah. So yeah. So the great question about what can we learn from aerospace and aviation, given and there's been so much cooperation among companies in that space when there have been problems and accidents. I don't think there's much cooperation yet between companies in your field or in this field. But what is that an area that you guys have thought about, tackled, discussed with other people? What do you say?
Well, the problem is not exactly the same, right? I'm sure the questioner knows that. I mean, there's been when people board a plane, and if you were to say, there is no pilot, the plane has technology that will fly itself, people feel like that makes passengers very nervous. And we hear the same thing about self-driving, although I totally agree that in the experiences I've had, once people experience it, they actually love it, or even find it a little boring, because they expected it to be a little bit more exciting. But what I do like from the aerospace industry is the digging deep into things that did go wrong, right?
And sharing
and sharing the information, right? And maybe that needs to be done through a third party so that companies feel really protected in terms of their own IP. And I think that makes a lot of sense.
Is anyone talking about this? Like, what's happening?
I've certainly talked to other companies about it.
Okay.
I think we're still in a very nascent stage where it's unclear who's winning, even among the players, even among the big players and the small players. It's unclear who's winning. So the perceived cost of data sharing is relatively high. To use an aviation example, I often say that when the Wright brothers flew their plane, they didn't have to deal with the FAA. One of our investors is building supersonic jets, and they'll probably have to spend tens or hundreds of millions of dollars before their first flight test. We're not quite in the 1930s of aviation yet. We're probably more like in the 19-teens. Though I think the pacing of regulation to force that type of data sharing needs to be done very specifically to match the pacing of the industry's development. So that doesn't shut it down too early, but it also doesn't expose the motoring public to unnecessary risks for too long.
Rather than have it forced, don't you think some players can do it on their own, right? And maybe there's a third party who could help facilitate that, but it doesn't have to be regulators, I agree.
Well, it seems like if Waymo is the more prominent of the developers out there, maybe that's an area where they can take a leadership position. Although if they're the leader, maybe they have less incentive to do it, right? Because they want safety to be the differentiator. But they've said that publicly. So I don't know. It doesn't seem like it's in the offing.
Well, comparing industries, I think maybe from the technical perspective may be dangerous, because you want to be very rigorous. And every industry has slightly different technical details that you have to solve and assure that they are safe. So just to answer your question, what's the differentiating factor? From the context of broader perspective, the volume and the cost is the differentiating factor. The cars have to be relatively inexpensive in comparison to building a plane. So on a plane, you may envision a situation where you have 3 redundant systems, whereas on a car, you're really going to have 2 just because of the cost, unless the cost is going to drop. And interestingly enough, the cost of compute drops. So in a sense, it's another quote for NVIDIA. But there are certain things that you just cannot compromise. And the serious players are not going to compromise on them.
Next question, I think over here there was a question. Yeah, go for it. So the question is, will there be a comparable path here where just like doctors, you would take kind of ethical courses and then take an oath to do no harm? I guess and what was the last part of your question?
Just how that affects the industry, sort of thinking, cost-wise, getting developers who have to take it.
But we just got done saying that there will be some harm, that some harm is inevitable in the process. So I guess I'm wondering what do no harm looks like in this case.
Well, I guess it's about the sort of stress that puts your developers underneath. So taking these ethics courses with doctors, they learn how to deal with the fact that
Okay.
lives are in their hands. So how do your developers deal with that?
So what does it mean to be ethical as an autonomous vehicle developer? Maybe we can start with that.
Yeah, so we actually just did brought our first executive on, and he's a safety lead. And the discipline of safety engineering is one that is less known in Silicon Valley, less known than it should be in the autonomous industry, but now something that I've gotten an intimate understanding of from interviewing people and talking to this guy. Safety engineering goes a lot into this. Some part of it is making it clearly safe for people's careers to raise the prospect of risks, changing the way that you talk about risks in an organization, and also sometimes deciding which risks are acceptable, which are not. If our truck's driving down the road and all of a sudden the highway turns into a roller coaster loop-de-loop, we're not going to develop a system to protect us from that. That's such an unlikely thing to happen. But on a much more serious note, there's a whole slew of what do we deem as acceptable risks for our system to be less good at, what do we deem as unacceptable risks. And that's part of how you allow your engineering team to feel comfortable thinking that they're not going to be responsible for the risky deaths of loved ones and random people.
Okay. All right, next question. Anyone? Hey.
How will insurance play into all of this? Will they kind of be like the FAA and police the industry, or be tangential and wait until there's a model that is figured out where they're purely focusing on economics?
So what role will insurance industry play?
Certainly a big role. You can compare this to space industry. In space industry, the whole insurance is really a big deal, and there is a high level that you have to pass to insure your satellites if you launch them. I think it's a little similar to autonomous driving. If you put L5 car on the road, let's just disregard the time. One day you put it on the road, it's going to be extremely expensive to insure it. So for the insurance industry, I think it's a disruptive domain to get into, and it's going to be very interesting to see how it is going to develop. It could go various ways, and you're welcome to start a startup on that if you have so many passions about it.
So I actually think the insurance thing is really neat, because that was also a thing we had to dive into. So fire insurance is an interesting thing. You can fire insure all of your individual homes, and if one of them burns down, cool, I pay it out. Or earthquake insurance, to be more appropriate, is the real problem, because if I'm just a friendly San Francisco earthquake insurance broker, I insure all of your homes, they're all in San Francisco, the big one hits, I go out of business, and none of you guys have money for your homes. So there's this whole class of insurance companies that some of you know intimately about, some of you know nothing about, reinsurers, who basically insure all of the different fire insurance companies, all of the different earthquake insurance companies. That's where they buy their insurance from, so that if all of their customers have a loss, they don't go out of business. That's exactly the shift that I think autonomous is going to go towards. For us to get our trucks insured, it's going to be a lot harder than signing up for Geico. That being said, there'll be fewer insurers who are directly insuring very large fleets, because if there's a fundamental flaw in any one of those fleets, there's the possibility of an extravagantly large loss across that fleet or across a big chunk of that fleet. So the insurance bit's going to be a cool change.
Have you done shipments yet, by the way?
Yeah. So we're regularly hauling freight with self-driving trucks. We have actual insurance for it, which is why I got to learn about reinsurers.
Through which company?
That is a clever strategic secret. But I think other people are now buying insurance from them too. But that took us 6
Not
to
a
12
secret.
months to find someone to sell us insurance.
Okay. All right. I think we're out of time. I think we're out of time, but maybe come up and talk to us when we're out. But thanks, everyone. Appreciate it.
Thanks.
Thanks, guys.